Good morning to all of you. In the last session, I have discussed about hierarchical routing algorithm, and I have covered all the points from your unit number 4. Right? Let me just go with the syllabus. Every points I have covered. By today, I will upload the PPT of this unit in your MFJ portal, and from today onwards, we will start with the next unit also, right? Which is data link layer. Just a second. And see, from the network layer, in terms of your knowledge, in terms of your like a viva or exam point of view, many important points are there in this unit, right? So make sure you prepare it very well. Like first we have discussed about the functionality of network layer, then we discuss about connection oriented and connectionless networks. In that we have discussed about virtual circuit and datagram. Then we have difference. We have also discussed the difference between that two functionality, right? See, connection oriented and connectionless. At a transport layer, it also provides that services. At a network layer, also it provides the services. So make sure you just understand this all the functionalities. Then we have discussed about routing mechanisms. So many points I have covered inside the routing, like it's methods we have discussed: static routing, dynamic routing. Then we have discussed about broadcasting, multicasting, and unicasting. Also, we have discussed about IP protocols, like we have discussed ICMP protocol, right? In a practical, we have discussed about DHCP, dynamic host configuration protocol, how it works. Then subnet I have covered. More important point, IP addressing, right? So that already in detail we have discussed. We have discussed IPv4, its header and its classes. Then we have discussed about IPv6, its header, and how it is differ, like the difference between IPv4 and IPv6. Then important point we have discussed, that is NAT, network address translation. So that are again important points of a network layer. And then we have solved many routing algorithms. Many examples we have solved, like a link state routing, distance vector routing, and yesterday we have discussed about hierarchical routing. So from the syllabus you can verify that each and every point I have covered, right? Now one unit is remain, which is the data link layer. So we know that it takes the services from the physical layer and will provide the services to network layer. In between, what data link layer will do? It have many functionalities, right? So that we will discuss step by step. Okay. As I told, I will upload a unit 4 PPT in your MFJ portal. Okay, so all of you just give the title for today's session, unit number 5, data link layer. Now, first, whenever we start any unit, right? So at that time we are discussing about the functionality of the that particular layer, right? Or like when we have discussed about OSI reference model, at that time in detail, like we have summarized the functionality of each and every layer. But how that is going to be implemented, or what are the core concept behind that functions, that exactly we will discuss in detail in this unit for a data link layer. Like if I summarize a few concepts, like a data link layer. So uh, physical layer will provide the data into bits, electric to bits. Now once it come to data link layer, so data link layer will convert that bits into frame, So framing is a functionality of data link layer. Now, how to form that frame, form the beat. For that, we will discuss mechanisms of the framing in this unit. Then we have discussed that data link layer also provide a error control. Like suppose I have sent the message, that same message is received at a receiver end or not. If there is some error means what? Like I have sent that hello, tomorrow you will have a CL lecture at a 9 o'clock. But at your end, you receive the message that tomorrow your CL lecture is cancelled, or sometimes time is changed. Like I have said 9 o'clock, but at your end you receive it as a 10 o'clock. So there is no meaning of that message. Students, just a second, due to network issue, I'm out from the meeting. Let me present my screen again. Second thing, once we have detected the error, so we have to correct that also. So for that, we will discuss error corrections method in this unit. Then we will discuss about MAC address Ethernet channel. That functionality we will discuss in a detail, right? So there are a number of functionalities or functions which are provided by data link layer. So the question is asked like list out or explain the functions of data link layer. Like in your mid one, question is asked for network layer. Same way for every layers, it have its own predefined specific functionalities, right? So you just give the title and then note down the points. A few points we will discuss next. Okay. Like you can go with this point which I have discussed, right? Flow control. We know that once the sender is sent, already I have discussed this point. So transport layer also provide the flow control, and data link layer is also provide the flow control. Half duplex and full duplex also we have discussed, so that going to be defined at this data link layer also. Now the question is raised that where exactly the data link layer is implemented in any devices, right? Because see, layer structures, that is okay, but how and exactly where these functionalities are working. So see, physical layer that also deal with the hardware devices or hardware component, as well as data link layer. It provides the services at both hardware as well as at a software. Physical layer only provide the services at a hardware layer. Hardware means what? The network devices you have used to create the network, and all the devices we have discussed, right? Like about a router, switch, hub, host. We are taking for the practicals. So related to that is handled at a physical layer, all the hardware devices. After that, we know that for the effective functionalities we are using the software also inside that devices, like a router we have discussed in detail. So in that we have learned that router is a one kind of hardware device, as well as it's have a software functionality inside it. So my point is what here, the data link layer, where exactly it provides the services. If we observe the closer look of our computer system, right? So it contains a many component like a CPU, central processing unit, then memory is there inside the devices. We need a controller and physical devices, or it can be input output, it can be printer, it can be another devices, right? So this how the hardware devices are there for any network. Now control unit will do what? Some commands which pass from the physical layer to data link layer. In between that, some controlling mechanisms are required. So that going to be handled by controller, right? Then suppose like a electric grids are generated. Now have to pass to the data link layer, and data link layer have to form the frame. So that is a kind of one control, like it's a switch between physical layer to data link layer. So that is the reason over here we need a controller also, and a CPU, central processing unit. It will handle all the functionalities. Another thing, NIC, network adapter card, or NSC you can say, right? NIC means network interface card, or you can say it as a network adapter card, right? You to access the internet in your device, whether it is your laptop or your desktop, you need that NIC card, and through that you are able to access the internet functionalities. So where it is located? It is located over here. You can observe in the diagram. Controller and physical functionalities in between over there, or this NIC card is there. In the diagram, that card is also given with the zoom form. And over here at NIC, this data link layer functionalities will be handled in any system. As I told, you need to note down the full name of NIC, that is Network Interface Card. It is a kind of one adapter, and it available on a chip. Like over here, that green one, that is a one chip, right? And in that, this NIC card was is there. That card is also, you can say it as a Ethernet card. And on that card, it implements the functionalities of data link layer as well as physical layer. And it is attached to host systems bus. Like in a COA, you are learning about types of buses. It's a address bus, data bus, and control bus. Right. So at that place, this card is available. And as I told that at the data link layer, it will provide the services of both hardware as well as software. So just note down this point also. Okay, now let's go with the next point. First, we have discussed about adapter at a one system. But in a network, when any sender will send the data, right? So at a data link layer, how this will work from one system to another system. So this scenario is given for data link layer, where a host is given, and inside view, this is similar to this controller, physical. Then this NIC card is available over there, CPU, memory, right? That same block, but one is sending side and one is at a receiving host. And as I told, the data will pass as a frame at a data link layer. So that scenario is given over here. And through the adapter, it will communicate from the sender host to the receiver host. Now let's go with the next point. We will discuss with the reference of this diagram. So one is a sender and another one is receiver. So sender said what kind of functionalities will be done. So first it will encapsulate, right? You have learned encapsulation, like transport layer will provide the services of encapsulating the data, right? When you add the header, it contains the many information and through which it will encapsulate the data. So encapsulates a datagram in a frame. Like at a transport layer, it will be in the form of datagram. Once it comes to the data link layer, it is in the form of frame. Or you can say it a reverse, like it depends on the direction. Like from the physical to transport, then from the frame to the datagram. And in the reverse also. So what kind of functionalities will be done at a center side? It will add the error checking bits. We will today discuss about one method, right? Checksum and how to calculate the checksum. With example, we will see this. So error checking bits will be added, RDT bits will be added, then flow control mechanisms will be there. At a receiver side, first it will check the is there any error is present or not, and all the bits which are set by the sender about RDT and flow control, that bits it will be verified at a receiver end. Like it will extract the data which is in the form of encapsulated and will check the details. If there is no error, then it will receiver will receive the data. One of the important functionality we will discuss, that is a checksum, right? Previous we have seen that error detection bits, like is there any error is present or not. For that checksum is used. Sender will calculate this, will add the value, and at a receiver end it will verify this. If both are same, then there is no error. If any of the bits are interchanged, so it will be considered as an error. So the question is raised that how to calculate the checksum. So we will go step by step. Mechanism is there to solve the given example, right? Like a two 16-bit integers are given over here, right? If you count that values, it is a 16-bit integers, right? So first what you have to do is take that 16-bit integers. Now you have to do a binary addition. Like few rules, you know that 0 plus 0 that is 0, 0 plus 1 that is 1, and 1 plus 1 at that time, 1 plus 1 will be considered as a 0 and 1 carry bit will be forwarded. These three things you need to revise. Already in your digital logic subject, digital fundamental, you have learned this, right? So according to that three things, you can solve your checksum example. So you have to start with your LSB, that is least significant bit. right? So over here the least significant pair, like we will go with the pair first and second integer, but we will start with the, you can say that the column. So first one is 0 1. When I speak, I will go with the every bit, and parallelly you just observe. Then I will give a time to note down this. And what you can do, you can do it by yourself also. Three rules you have to remember. 0 plus 0, that is 0. 0 plus 1, that is 1. When you get 1 1, at that time you have to be very careful. Like 1 plus 1, so that current bit is 0, but you have to forward a 1 carry bit. Otherwise your outcome will change. You will not get the correct outcome. Okay, so 0 plus 1, that is 1. 1 plus 0, that is 1. Now third bit, that is 1 plus 1. So over there you have to put the 0, but 1 carry bit will be forwarded. At a fourth position, 2 bits are 0 0. So 0 plus 0 is 0, but 1 carry bit is there from the previous one. So that is the reason at a fourth position the answer is 1. Next one, 0 1. So 0 plus 1, that is 1. After that 1 plus 0, that is 1. Again it is 1 1. So 1 plus 1 0, and 1 carry bit you have to add. At that position 2 bits are 0 0. So 0 plus 0 is 0, and 1 previous carry bit. So that you have to add, so it will be 1. After that again 0 1. So 0 plus 1, that is 1. Next 1 0. So 1 plus 0, 1. Same way next, that is 1 1. So 1 plus 1 0, and 1 carry bit will be added. Again over there the same condition like was 0 0. So 0 plus 0, that is 1, and 1 carry bit you have to add over here. So that will be 1. Now if you repeat this at the last, you will come 1 plus 1, that is over here, see, yes. Second last step you just observe, that is 1 plus 1, so 0, 1 carry bit over there. Now at that step again a 1 plus 1. So first you have to solve that. So 1 plus 1, that is 0, and 1 carry bit you have to forward. Now that 0 plus you are having a 1 carry bit of the previous one. So that is the reason at that place 1 is written over there, and at the last you are having a carry bit 1. Over here you have to remember the two conditions. Two possibilities are there only. First you have to do addition. At MSB, most significant bit, you have to check. If the carry is 0, then it's okay. But if the carry bit is 1, like in our given example, so at that time you have to do a wrap around. Wrap around is nothing but you have to add that MSB of 1 with the LSB. But which LSB? The final addition outcome. The sum already you have done of that binary. The value you are having, you have to do a wrap around. That round is done, and arrow is indicate that you have to add that 1 MSB to the LSB. See, that arrow is end at the last bit of this given input. Now again you have to repeat the same process, right? So 1 plus 1, that is 0, 1 carry bit is forwarded, right? Then 1 plus, again see, you have to simply do the summation, right? So 1 plus 1, that is 0, and 1 carry bit is forwarded, but over there it is 0. So 0 plus 1, that is 1. So at a third position you will get a 1. Now remaining bit as it is you have to take. Like after a third position there is no further carry bit to forward. So at that time don't worry, just take the bits as it is. Then you have to do a ones complement. Like this is the whole process is one complement. Like first you have to do addition. If any carry bit is there, wrap around it, and then do a complement. Complement is what? If it is 0, take it as a 1. If it is 1, take it as a 0. Like if you start again, you have to start this with the LSB. So first bit is 0, so just interchange it. If it is 0, then put 1. Second one is also 0, you have to put 1. Third one is 1, you have to write it 0. 1, 0, 1, 0. If it is 0, write it 1. So that final outcome is considered as a checksum. Till now, at many concepts we have heard about checksum, but this is how in any packet or any frame, this how checksums are calculated and this value is added. Basically, checksum are used for error detection. So first, all of you just do what? Note down this whole example. Then I will give you some example which all of you have to solve right now. So make sure you note down this example. And it is asked in exam also, right? For solve. Done? Okay, so all students just solve this example. Two examples, one by one. Every student must have to solve this. Find the answer for the checksum. I will ask any random students, right? Once you're done, just give me a notification so I can go with the next point. So I can come to know how many students are solving this example. No one? Or you are doing it? Give some response. Okay. Yeah. Because see, it's a need of time. Like when you are working with the binary, you need to be very careful. If only single place, what I need to repeat. See, first go step by step, and that is the reason over here I need to note down this. Three things I told you to. Okay, let me solve it. Or the unsolved example, right? This one. We will go with this. Just give me a second. It's very easy. If you go step by step, you will get this, right? So this is the same value I have taken over here for my reference. Okay. So let me just write it, right? Because that I have passed over here only. Like one, we will put a space so you will get. Right, so this is a given input. Next, first step, what you have to do is first we will start adding from the LSB. Okay, so that means you have to start with these two bits. Simply you have to do additions. So 0 plus 1. So that, see, let me write it over here so that it will be very easy. 0 plus 1. This is binary summation rule, so you have to remember it. Then sometimes you will get 0 plus 0. So that you have to consider 0. Now you have to be extra careful when you have a 1 plus 1. So at that time, for that row, for that column, you have to put 0 and carry bit 1. Carry bit means what? So once that point will come, I will cover over here. Okay. So now I will do one by one. First, I will do for this bit only. So 0 plus 1. So which condition? First one. So answer will be 1. Okay. Now the next bit is what? This 1 0, right? 1 0. So again that is like if it is 0 plus 1 or 1 plus 0, both will be considered as a 1. So for this bit value will be 1 plus 0 1. Okay. Next one is 0 1. So value will be 1. Next is 0 1. So again outcome will be 1. Next 0 1. This is 0 1. So you have to write 1. See, I'm not like it's going not I'm not writing in the same sequence, but you have to understand this, and you have to write in the same row. Yes, yes. Then 0 0, so that will be 0. Next again 0 0, so that will be 0. Let me complete it so it will be more clearer to everyone. Yes, now at this point you have to be extra careful. 1 plus 1. So what I told, 1 plus 1 means at that position you have to write 0. But 1 carry bit you have to forward. So 1 plus 1 over here I have to put the 0. In that carry bit you have to first write it over here at the next one. So that 1 value will be over here. Now see, 1 plus 1 that is 0. And 1 carry bit you have to forward. But for this carry also you have to consider. So that is 1 plus 0, 1. So over here you have to write 1. Then 1 plus 0 that is 1 and 1 carry bit. So 1 plus 1. Again you have to put 0 over here and that carry bit will be over here. That 1. Now 0 plus 0 that is 0. 1 carry bit is over here, so you have to write 1. Next 0 plus 1 that is 1. 0 plus 1 that is 1. 0 plus 1 again 1. Now 1 plus 1, so that is 0 and 1 carry bit will be forwarded over here, so that is 1. Now 1 plus 0 that is 0, but 1 carry bit is there. So that will be 1 plus 0 1 and again 1 carry bit. So 1 that is 1 plus 1 over here it is 0 and 1 carry bit will come over here. MSB. So for that what we have learned, suppose you are getting this over here, right? So you have to do wrap around. Like just come to this point over here and you have to add 1 bit over here. 1. So start again for this 1 plus 1 0 1 carry bit, right? In that manner. So that is again 1 1. So 1 plus 1 0 1 till this that carry will come, and again over here 1 carry bit will come. So that is 1 plus 0 1. Then remaining bit will be as it is, right? So just complete in this way. And at the last step, you have to do a complement. So this how I was explaining, and you have to solve this. So just note down this point, and also you have to solve both the examples. Meanwhile, let me start the attendance. 917109,
Present.
180, 222,
Yes, ma'am.
41,
Yes, ma'am.
68, 69,
Yes, ma'am.
70, 71,
Yes, ma'am.
73, 74,
Yes, ma'am.
75,
Yes, ma'am.
76,
Yes, ma'am.
77,
Yes, ma'am.
78,
Yes, ma'am.
79, 80, 81,
Yes, ma'am.
82,
Present, ma'am.
83,
Yes, ma'am.
84,
Yes, ma'am.
85,
Present, ma'am.
86,
Yes, ma'am.
87,
87 present, ma'am.
88,
88 present, ma'am.
89,
89 present, ma'am.
90,
Present, ma'am.
91,
Yes, ma'am.
92,
Present, ma'am.
93,
Yes, ma'am.
95,
Present, ma'am.
99,
Yes, ma'am.
100, 101, 102,
Present, ma'am.
105,
Present, ma'am.
106,
Yes, ma'am.
108, 109, 111, 112, 130, 133, 150,
Yes, ma'am.
155, 926 is 1,
155.
155. Okay. 926 is 2, 3,
Present, ma'am.
4,
Present.
5,
Present 5.
6.
6.
Okay. 7,
Present.
8,
Present.
9,
Present, ma'am.
11,
11 present, ma'am.
13, 15, 16,
Present, ma'am.
17,
Preacher, ma'am.
18,
Present, ma'am.
19, 20,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
24, 25,
Present, ma'am.
41,
Present, ma'am.
42, 44,
Present, ma'am.
45,
Present, ma'am.
46,
Present, ma'am.
47,
Present, ma'am.
48,
Present, ma'am.
49, 50.
Yes, ma'am.
Thank you all of you. Have a nice day. Be safe at your home only. You can leave now.
Ma'am, 130 present network issue.
Which number, Darshan?
Yes, ma'am.
Number.
130.
Okay. I will